Hi, I follow along with Paul McWhorter's Raspberry Pi Pico W lessons, and we're on on lesson 52 with Neopixels. And I've been fascinated with Neopixels ever since I got into Arduino more than 10 years ago. Anyhow, Paul did a pretty good introduction of how the Neopixels work and how the each little pixel takes the data it needs and strips it off and sends the rest of it along the strip, and did a pretty good job on that. Um, so got to commend him for that. Anyhow, a little bit farther along in here, he wanted us to basically do something where we're uh, having the green pixel travel back and forth on the with the red pixels in the background. And basically from night it's a variation of the Knight Rider. The Knight Rider car from the 80s or 70s or whenever it was, had that thing on the front of it, and that was always a big deal for um, Arduino and people learning Arduino. Everybody had to learn how to do the kit thing, and I taught a lot of kids how to do that. When you increment up and you check it to the top of the number of pixels, and then you drop out of the loop, and then you decrement down to 0, and then you go back through the loop and do it all over again. And so I taught many of students how to do it that way when I was doing my library programs, and uh, doing that was always a big hit, and taught a lot about loops and everything else in uh, programming. Of course, with the Arduino, we were in C++. So anyhow, this was what the homework was. So it's pretty basic. As you can see, I have it running. I happen to have this 60 pixel it's flexible uh, NeoPixel thing with edge-lit pixels and silicone wrappers. So it kind of uh, kind of cool, and you can wearable type thing where I just got it draped over my shoulder. You can't make sharp bends with it, or it might break the PCB. But it's pretty flexible. You could probably bend it into a 2-inch radius with no problem at all. So anyhow, as you can see, I have it going on here. So let's get to the code. So as I said, I taught my beginning students how to increment and decrement, and somewhere along the line, I come up with a better or a quicker way of doing it, less code, and probably less clear to people. So I probably wouldn't teach beginners that, but I like to show off a little bit. What can I say? So we're doing the import of the uh, ADC. I just copy and paste that from my other demo that I'm going to show a little later. But we're just importing from Neopixel, get to Neopixel, get to time. And like I said, this is a 60 pixel strip, and I'm on pin 16. So we're making that an output pin. And then we're setting up, and I'm calling my strip pixels. Um, and like I said, number of pixels in the pin is all we're doing. So for this on our while true, I have a couple variables I use. I have the index, which is what we increment and decrement, and I have the direction, which I initialize as 1 to begin with. And direction is either going to be a positive 1 or a negative 1, and I'll show you why that is a little bit farther down. So the first thing we do is our pixels.fill. And like I said, just so you guys don't get overwhelmed with the color, I got it just 10 out of the 255 on there. And same way with the green, just a 10. And do that. So the way it works is if you fill the pixels with one color, and then your next line, you're setting a single pixel to another color, it just overwrites whatever the fill was. So as long as you do your fill first, a lot of my examples, you want to start out with a blank screen. So I fill, a lot of times I'll fill 000 all the way across. And like I said, and then whatever you do, you're starting from a blank canvas, so to speak. And so this is just, you're turning, instead you're having a red canvas as your background and you're just overlaying a green pixel, one green pixel on it. So here's how we do our, like I said, we're doing that and we're using our index. So um, if I wanted to use the whole strip, I would have started at 0 as the index, but as you can see, it kind of goes off the screen and goes over to the Pico W. So I just started at 20 out of the 60, so it's only going over part of them. So like I said, you could use that as 0 for sure. And so we're putting it, starting at 20, and then we're doing our pixels dot right with the updated thing. And then I'm adding index plus equals direction. So right now direction is positive +1. So it's going to +1. So index will be 21 next time through. And then we check to see if index is equal to 20 or index is equal to num pixels -1, you know, because they're index 0 base. So we're checking to see if it's 59, which is the last pixel in line. And then if it is, all we're doing is multiplying the direction by a -1. So direction times equals -1. So if direction is 1, it's going to become -1. But if you multiply a -1 times a -1, you get a +1. So all you're doing is flipping this direction between a +1 and a -1 as you're doing it. And then we're just sleeping for 1/10 of a second. So instead of having, like I say, increment and then stopping and then do a decrement and then just looping through, this just does it all in 7 lines of code. So kind of interesting. Like I said, just the quickest way I could do it. I'd like to see if anybody can come up with a faster way, less lines of code to do that without putting more stuff on one line. But anyhow, I, probably if you use the 4 loops, you'd probably end up with, you know, a dozen or more lines of code. So it doesn't save a whole lot. But I just like to find the most efficient way for me to do things. So anyhow, that's the homework for Paul, and hope everybody gets the homework in whatever way you want to get it done. But I got a little bit more I want to talk about. So I see a little bit farther along that Paul's going to do like a rainbow effect with his pixels. And from the description of the title and the description of the video, looks like he's going to go to his HSV again. I think when we were doing the RGB single pixels, I think I might have mentioned this in the past. It's sort of a gripe I have of the way he does it. So I actually put a little picture together showing what Paul does and what I think is the better way. And it's not my idea. Adafruit's been doing pixels since before I came on the scene, and then probably since I think the new pixel library came out in 2012, so probably a dozen years ago. They've been doing pixels, and we'll talk about that in a second. But let's talk about the way that, let me get myself out of the way here. So when Paul was doing the RGB, when this is how he did it, and he had one pixel all the way on, one pixel all the way off, and the other one moving. And that works out pretty good because, like I said, for the red and the blue and the green, you got one pixel all the way on, which is what you should have. But my gripe is that when he gets to the magenta, he has 2 pixels all the way on. So there's no way that 1 pixel is going to be as bright as 2 pixels all the way on. So to me, I don't think that this is a fair representation. I don't think you should have 2 pixels all the way on there. And that's certainly not the way I learned it with the Adafruit way. In the same way, when we get over here to, let's see, blue and green makes yellow, I think. I don't know. I can't remember. And same way over here, you got 2 pixels on all the time. So I added in what I had to create my own sketch here of what Adafruit. Adafruit has what they call the wheel function. So I'm just going to say it. Paul, why are you reinventing the wheel? Adafruit's been doing it for a dozen years, and it's a better way than what you're showing here, in my opinion. So anyhow, so what they do, instead of having on and off, they have 1 pixel off, and then they have 2 pixels moving. And then as the red comes down, the blue goes up. So when you get to this magenta, both of them are at half brightness. Now, yeah, we can say that, okay, it's not, pixel brightness isn't based on linear, it's based on, exponential values, but at least this gets you somewhere where you don't have all the color. Plus, by doing this, as these two come together, you are ever only going to get the amount of current of 1 pixel for each pixel you're doing. You're never going to get more than that. With his, you got, if you're worried about how much current you're spending twice as much current on a magenta as you are a red or a blue. So anyhow, and then, like I said, it just continues right through magenta, and then it ends up all the way down where the red is 0 and the green is 0, and you only have the blue left. So you still only have 1 blue. And then you switch to that the red stays low and the green starts to come up, and the green and the blue kind of come in together. And then they continue on and green comes in. And then the blue stays down, and it just does that. Anyhow, when Paul coded this up, he had about 27 lines of code to do it this way. And we'll go ahead and get out of this, and we'll go over and we'll bring up the thing. So the wheel function from Adafruit, of course, was in C++. I just basically did the same thing here in for Python. It's the same length and same way they're doing it. So, and it's only a total, the whole function is 9 lines. So, where Paul was doing a 360 degrees circle, which I guess is better for trying to figure out where you are on the thing. Adafruit, like I say, these little Neopixels, I've had them working on the ATtiny 85 with very little memory and RAM and everything. And so they care about how big your how big of data you're using. So what the wheel position does, it uses a 1 byte, so 0 to 255, and they can use it as a byte and save a whole lot of things. I don't know what, like I say, with these new microcontrollers, we're not worried about how much memory we're using because we got lots to spare. But on the older microcontrollers, we did it. So instead of 360 in our total circle, we got 256. So our red is at 0, and then our blue is at 85, and our green is at 170. And basically, like I said, what we're doing is we're dividing that circle up into 3 sections, and depending on which section it falls in, we're having a if statement, and we're just returning what we're doing. And like I said, in this first section, we're between red and blue. So our red color is going to be whatever the number is minus the position. Remember, our position is going to be a third of the 255. So we have to multiply it by 3 to get back to our 255 range. So we're 255 minus whatever the number is. And then of course 0 for the RG green, and then the blue is position times 3. So this one, like I said, this is 255 minus position. So as position increases, this value is going to go down. As position increases, this value is going to go up. So that's why you're going to get more blue the farther along, closer to 85 you get. And when you get to 85, it'll be all blue. In the same way down here, we're just checking if it's less. Since we got an if here, we know it's either going to do 85 and return out of it, which it won't continue doing this. But if it's greater than 85, then we're going to see if it's going to be less than 170. That means that it's going to be in between these two. And then again, we just got to subtract the 85 from it, so that we get this number between 0 and 85, so that we can do our multiplication. And this time we're leaving the red out, and it's going to be between blue and green. And then, of course, on the third one, we're just leaving we're checking. We know that it's greater than 170, so we're subtracting 170, so that'll give us a number between 0 and 85. And then we're doing the same thing, and this time we're leaving the blue out, so it's going to be between green and red color. Anyhow, so that's, like I said, Paul used 27, 28 lines of code to do his conversion between HSV and RGB. We're doing it in 9 lines, and I think it's super simple. And I just can't imagine why you would why you would reinvent the wheel to go from HSV. I know Paul likes to do the math and everything, but this math has been done for 12 years, and it works, and it just works. So that's all it is. So when you're calling this wheel, all you're doing is calling a single number between 0 and 255. And most of the time when you're doing a rainbow, you're cycling through it, so you don't care where the rainbow is. I mean, it's easy enough to know that blue is 85 and green is 170, and stuff in between that. But when you're doing rainbow stuff, you just want to kind of cycle through the whole rainbow, and you're not worried about which actual color you're getting. Anyhow, so I've got several functions. I'm calling this my Neopixel demo.py, because I brought in several of the things that I used to do in C++ Arduino. So this is we have a rainbow wave where the colors kind of move along the strip and change colors along the strip as they go. We have a rainbow static where the colors of the whole strip change at once, however long the sleep time is in between those. I got a sparkle here where it's just kind of just randomly picks a white color. The sparkle strip. Sometimes some of my younger kids kind of like that, like a rainbow sparkle type thing. I'm not a rainbow sparkle, is white, but you could do it in a rainbow as well. One of my favorites is this bounce thing, and it just has 2 pixels, and it's basically doing the kit thing, but there's 2 of them going in opposite directions, and it's pretty easy to see the thing. And all we're doing here is the single pixel. Each time it reaches the end, it changes to a different random color on the what do you call it? The bounce actually doesn't change the color. That's why I was confused here. I actually do the color when I call bounce. I call it as a different color each time. So it's going to do, this function is going to run pixels from one end to the other and from the other end to the first one, back and forth. And then it's going to go down and it'll call itself again. I have one here called rain, where it kind of just looks like, rain coming down the pixels. you almost need like a whole curtain of pixels for it to look like rain and have it randomized and everything. It doesn't look that great in just a single strip, but um, I've seen somebody's had like 20 strips of pixels and it looks amazing. It almost looks like rain coming down. So, okay, so in my wild true, I just have a bunch of the things um, commented out. Right now, I got the rainbow static on. I also have a potentiometer up at the top. I set up a potentiometer so I could change adjust the speed of these changes on the fly. So just to get a better idea. Some of them I use it like this rainbow static. I'm not using that. I'm just using a 0.1. Anyhow, let's go ahead and get this and let's see it run. So this one, like I said, you can see it's starting out as red, and this is the static one, and it's slowly changing to magenta, then the blue, and then blue to the cyan, and then to the green, then towards yellow, and back towards red, and it'll start all over again. So that's kind of cool. I guess I can make myself a little bit bigger here so you can see what's going on. So we'll comment that one out. And now we'll do the wave one where this one, the part that comes along the changes come along the thing. So you can see this is the tail end of it, but it's the green's coming in, yellow, and the red. And you can see both sides are different. Starts out blue, and then the blue kind of just goes through it. And then teal, and then into the yellow, orange, red. We should go back to magenta towards blue. Now this is on 100%, so I didn't change the thing on that. As you can see, you know, if you diffuse that a little bit more, you could actually make that almost look like a neon light type thing, but it's not quite where you could do that. You can still see individual pixels, but it's a cool event. Then, like I say, they're side lit, so you could actually slide this. This is a rectangular form of this, so you could actually cut a groove out in like a piece of wood or something, route a groove out, and you could actually work this down into it and make a pretty cool sign or whatever. So that's kind of cool. All right, so let's get out of that one. Sparkle I'm not going to do, but the bounce is kind of cool. So let's do bounce. And stop this one. And we'll see. So you see how they passed over there? So you got one at the start and one at the finish. And it should change color. There we go. So it's a random color change on that. So this is a nice easy one that gives you a pretty good effect, especially on a longer strip like this. Short, that 8 pixel strip, it's probably not going to do much, but it's kind of cool on this one. Also, it's kind of cool if you have like a 24 ring of pixels. It's kind of cool on a ring of pixels too. I didn't do a couple of them. We have what we call the wipe, which kind of starts at the beginning and does all the colors. And on a ring, they really look good because it looks like, you know, you're part of a clock or something that you're wiping. And uh, like I said, when I was doing Arduino, we spent way too much time on Neopixels, but it's a good way to learn about loops and different ways of doing things. And so it was good. Anyhow, so that's pretty much all I got for today. Oh, I have one more thing. So I use my PIco. I plug it into I got a laptop and it doesn't have enough enough USB ports. So I have a USB hub here. And I don't know whether it's because it's the USB hub or the computer or whatever, but if I run this, you can notice that I have these actually because I get the brackets. That means that they are on the Raspberry Pi Pico, but I am running them from Thonny. And there must have to be communication, serial communication for this to continue to run, because if I leave it plugged in, like I say, Neopixels, you can sit there and watch them all night if you're all day and all night if you want to. And I'll leave a full thing going, and I noticed that they stopped. So first I had it running. I had the program up here on the computer and just ran it from there, and it would stop. So I said, well, let's put it down on the Pico. And I did the same thing, but it stopped there as well. And so it must need to have communications, even though the program itself is on there. It, the the whole thing stops if you run out of even though the hub is powered, USB hub is powered, there must be like a glitch where it loses or resets for a second or something. And like I said, I don't know why it was. So if you with Arduino, you never had to worry about that, because once it was on the thing, if it was plugged in to wherever source of power you had, it would just run and run and run until it was done. So what I've had to do here, as I've mentioned this in another one, is that we still have the NeoPixel demo down here. That's this one. The rating's a little bit small, and I haven't figured out how to make that any bigger without, making all my fonts bigger on my whole computer. But we also have a main.py. Oh, I have to stop it to get that done. So let's stop this one. And now I can get the main.py up here. So main.py, and remember on my one about over-the-air updates, I mentioned this, that rather than I want to keep running this, changing this NeoPixel demo, adding things to it or changing the speed or whatever, I don't want to have to worry about what's in the main.py. So I don't have my NeoPixel demo in the main. I have an import to neopixel.demo. So whatever the current code that's been saved in neopixel.demo, when you unplug it and plug it back in, it's going to import whatever that code is and it's going to run it. So like I said, right now we got that going on. I'm going to go ahead and unplug my thing, and I should have the bounce come back because that was the last one that we saved. And as you can see, we got the bounce, and I found out I've left it on for days on end, and it doesn't matter, because you can see down here in the monitor area here that it's not connected at all to the Thonny at all. This is just running off the Pico W by itself. So you shouldn't, as long as it's plugged in, you should get this to run and it shouldn't stop. First, I thought, well, there must be a glitch in the NeoPixel library or something, but no, it's just my USB would glitch out. It may be some people or most people won't have that problem, but I sure did. Anyhow, I have been talking way too long. Thanks a lot, Paul, for all you do. And I know you've already got the HSV code done, but I'd hope you'd look into the wheel library that Adafruit does. It's so simple and it works, and it just, been around forever. Why reinvent the wheel? Have a great day, everybody. Thanks.